recorded. Thank you. Thank you to whoever reminded me to record. So this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. So if you look, this angle theta, it's in quadrant 1. But this angle theta over here, it's ending in quadrant 2. So it's where the angle is ending. So this angle here ended in quadrant 1, this angle here ended in quadrant 2. Does that make sense? No problem. Okay, so let's do an example. So, for example, let 2, -3 be a point on the terminal side of theta. Find the values of the 6 trig functions. Sure. Yeah, I can go back for you. Yeah, not a problem at all. So let me let people write that down. No problem. Okay, so we've got 2, -3 is a point on the terminal side of theta. Find the values of the 6 trig functions. So the first thing I'm going to do is I'm actually going to plot that point 2, -3. So it would be 2 this way, -3. So we're talking about a point here. So our angle theta starts and ends up ending here. So it starts here at 0 and it circles all the way around, and so that's our angle theta, and it ends at that point that is 2, -3. So I want to make that reference triangle, and that reference triangle is always going to be drawn up or down to the x-axis, right? So remember, the x-axis is that horizontal line. So we're always going to be, when we're making our reference triangle, we're always drawing a straight up and down line to make the triangle connect with that horizontal line. So I'm going to draw this line here, and that gives me a right triangle. And I happen to know how long 2 of the sides of that right triangle are. So this side here, right, because this is the point 2, -3, this side here we know is 2, and this side here is -3, right? So it's 3, but it's going down. Questions on any of that so far? Okay, so to find the values of the trig functions, I'm going to need to find the hypotenuse, right? So how would I find that hypotenuse? What am I going to use to find that? Yeah, so the 2 and the -3 are the x and the y. Yep, because it gives you the point. So anytime they give you a point, right, when they give you a point, the first number is the x and the second number is the y. So the 2 is the x and the -3 is the y. And yeah, we're going to use the Pythagorean theorem. So to find that missing side, we're going to have a squared plus b squared equals c squared. So 2 squared plus -3 squared equals c squared. So 4 plus 9 equals c squared. 13 is equal to c squared. So c is equal to plus or minus the square root of 13. But since we're just dealing with the hypotenuse, and the hypotenuse is always positive, this is going to be the square root of 13. How did I know? Okay, so angles, right? angles are always going to start, when we start with an angle, it's, so think about it, like when I'm making an angle, it's like I have the two sides, and the one side stays stationary, and the other side flips open and rotates around to make the angle. So the two sides start here, and then one side opens up and it rotates around, and it's stopping at this point. So it's rotated around this way to stop at that point. Does that help? No problem. Any other questions? No. Okay, so now I want to figure out, so now I have my triangle, and the thing is that, I know inside here, right, this is theta prime, so that's that angle we're going to be working out from, so all of our trig functions for theta is going to be the same as for theta prime. And so we're looking for the sine of theta. So the sine is, remember, the opposite over the adjacent, or the y over the r. So our y value here was -3, and our r value was the square root of 13. The cosine of theta is adjacent over hypotenuse, or our x value over our r. So it's going to be 2 over the square root of 13. And the tangent of theta is going to be the opposite over the adjacent, or the y over the x, so -3 over 2. So questions on how I got any of them? So theta prime, so theta prime is what's called a reference angle. It's the angle that ends up inside the triangle that you make. And so theta and theta prime, basically, we don't usually so I put the theta prime in there just because you want to think about it's going from the perspective of that angle. So when we're talking about opposite and adjacent, we're talking about from the perspective of that angle. Theta and theta prime, when we're trying to find the sine, the cosine, the tangent, the cosecant, the secant, the cotangent, all of those have the same values whether we're talking about theta or theta prime. So that's what theta prime is, what's called that reference angle that I said on the last slide. Does that help? Awesome. Any other questions? No. Okay. So to get those other values, we're just going to flip these over, right? So the cosecant of theta is going to be negative square root of 13 over 3. The secant of theta is going to be root 13 over 2. And the cotangent of theta is going to be negative 2 over 3. Questions? Can we do one more example? Sure. Are we okay for me to go to the next page? Yeah. Okay. Okay, so let's let -1, -4 be a point on the terminal side of theta. And again, we're going to find the 6 trig values. And I said the hypotenuse is always positive. Yes, the hypotenuse is always positive. But it doesn't matter when I it doesn't matter where you put the negative, right? So I know it might look like I put the negative with the hypotenuse here, but this is just saying like, it doesn't matter where you put the negative. If you wanted to put the negative down in the bottom of the fraction, you can. We just usually don't put negatives in the bottom of fractions. We either usually put them out in front of the fraction, kind of like I have here, or we put them up at the top of the fraction. So either one of those works. Why did I put the negative? So I put the negative because I have here, this side of the triangle, right, is -3. Like, it's negative. So to get to this point, 2 comma -3, I have to go down to -3. So that is negative. Yeah, so y theta and theta prime have the same trig values is basically the way that we have defined, mathematics has defined trig values on angles that are bigger than 90 degrees, right? So last class, we dealt with triangles where all the angles were less than 90 degrees. So then in the way that we define, how can we extend the trig values beyond angles that are for angles that are bigger than 90 degrees, we have to make this reference triangle, and then we use that reference triangle. And so mathematicians, we've defined it to be that the trig values for the reference triangle are going to be the same as the trig values on the angle. So it's basically when trig was invented, this was part of the definition. Does that sort of help? No problem. Okay, so back to our new problem here. Okay, so I've got -1, -4 is a point on the terminal side of theta. Find the 6 trig values. So I'm going to graph that point. So that point here, so this is -1, and then we're going to go down 1, 2, 3, 4. So we have a point here. So our angle theta goes all the way around to that point. And so this is a right angle that's made there with the axis. And then this side here was -1, and this side here I went down, it's -4. Questions? Okay, just like before, I'm going to use the Pythagorean Theorem to help me find the hypotenuse. So a squared plus b squared equals c squared. So -1 squared plus -4 squared equals c squared. So 1 plus 16 equals c squared. So 17 is going to be equal to c squared. So plus or minus square root of 17 is going to be equal to c. And then we want the positive part for the hypotenuse, so it's just going to be the positive square root of 17. And so now we're just going to read off those values. So the sine of theta is the opposite over the hypotenuse, so -4 over the square root of 17. The cosine of theta is the adjacent, -1 over the square root of 17. The tangent of theta is the opposite, -4 over the adjacent, -1. Now, -4 over 1, right, I can simplify. That's just +4. And then we're just going to flip them over. So the cosecant of theta is -square root of 17 over 4. The secant of theta is -square root of 17 over 1, which is just -square root of 17. And the cotangent of theta ends up being 1 over 4. Okay, how do you know which angle you're looking at? Good point. You are always, so the reference angle is always, first off, the angle that's tucked in, that's attached to the origin. And it's always going to be in that triangle that you made. So we drew that triangle up to the x-axis, and then it's always going to be the angle that is touching into the origin here that's inside the triangle. So this angle here is the angle that's inside the triangle that's attached to it. And so that's my reference angle. That's the angle we're using to figure out what's opposite, what is adjacent. Does that help? No problem. Other questions? No. Okay. So you might be given a point, and then you have to find the 6 trig functions. So let's go back. Let's talk a little bit more about the reference angle, because going forward for what we are going to do, being able to find the reference angle for an angle is helpful. So, all right. So a little more on reference angles. Okay, so the first point, right, is the point I've already been making, that, so theta prime is the reference angle for theta. And theta prime is found by drawing / making a triangle with the x-axis. Theta prime, right? So again, as we said, the definition, so the values of the trig functions for theta and theta prime are the same. Okay, so for us, for right now, finding the reference angle finding the reference angle doesn't help us all the time right now find the values of the trig functions, but sometimes it does. So, for example, so the first thing we're going to do is we're going to practice finding the reference angles. So, find the reference angle for, okay, A, theta equals 285 degrees. So, 285 degrees, right, starts, so remember each quadrant is 90 degrees. So if I start my angle 90, 180, 270, so 285 is a little bit further. So this would be that angle, this is theta. So theta, 285 degrees. To draw the reference triangle, I have to draw up to the x-axis, right? So remember, the reference triangle is always up to the x-axis. So all the way around here, right, this pink part here, when I circle around, that is 285 degrees. And I want to figure out how much is that angle inside the reference angle, theta prime, the green angle. So anybody have any ideas how I could figure that out? So theta prime. Yeah, so if I were to go all the way around, right? So if I start the pink angle plus this green angle, which goes all the way around, that is 360 degrees. So this little green part is the total amount, 360, minus the pink part, 285. So it's going to be 360 degrees minus 285 degrees, which ends up being equal to 75 degrees. Now, here's the thing about reference angles. It's not a one-stop shop. It's not like every single time you just do 360 minus the angle and you'll get the reference angle. You actually have to think about them. So I want us to be careful about that. Questions? Okay, so let's look at another one here. What about theta equals 120 degrees? So 120 degrees, right, is in quadrant 2 here. So this part here is 120 degrees. To make that reference triangle, I'm going to drop down. And so in here, that's what we're looking for, this theta prime. So any ideas how I could find that green theta prime this time? Yeah, so if you notice, and I'll make it pink again here, this pink part and that green part, together they make a straight line, which is 180 degrees. So here it's going to be 180 degrees minus 120 degrees, or 60 degrees. The arrow always starts in quadrant 1, yes. All right, should we do another one? So C, what about theta equals negative 108 degrees? So remember, negative angles usually our angles start in quadrant 1 and they rotate counterclockwise. Remember, negative angles rotate clockwise. And I know it's kind of weird because probably the way you're watching it, it's okay. So negative 108 degrees would bring us to someplace in here. So I rotated this way to get the minus 108 degrees. So this pink part, right, is minus 108 degrees. I'm going to make that reference triangle. So we're looking for this green part in here, this theta prime. So what would anyone want to take a guess what we would do to figure out what theta prime is? Okay, so the arrow didn't go up this time because the angle was negative. If the angle is negative, you go the other direction. Yeah, so we're going to take 180 minus 108 to figure out what we have left there. So 180 degrees minus 108 degrees gives us 72 degrees is that reference triangle, that reference angle. All right, then my last example here. So you could be given them in radians, so 7 pi over 6. You could work in radians if you want, or if you're in radians, you could translate it to degrees. The only thing is, once we get an answer, we have to go back to radians. So 7 pi over 6, if I convert that to degrees, I'm going to multiply by 180 degrees over pi. So 6 goes into 180 30 times. And my pi's would cancel. So we're going to be left with 210 degrees. So if we think about drawing something that's 210 degrees, 210 degrees is going to put us down here in the third quadrant. So 210 degrees. Again, I'm going to make that reference triangle. So this reference angle is just going to be the part that's in here. So what would we do to find how much is in there? If the whole thing is 210 degrees, how am I going to find how much that little piece is? I mean, the 6, you could say like 2 goes into both of them first, and then 3 goes into both of them. But the 6 is always, it's not going to cancel out with anything else, any other piece of that. It's always just going to go into that 180. You could say 6 goes into 18 3 times, and then you still have that 10 left over. Okay, so yeah, so let's see. So we got a couple different answers. So we had 180 minus 210. We have 270 minus 210, 270 minus 210. We had a 210 minus 180. Okay. So let's talk about a couple of these. The 270 minus 210, which a lot of you guys are saying, 270 brings us all the way to here. And if I subtract off the 210, I don't end up getting the green part. That would give me this part. So this angle here is 270 minus 210. So that's not getting us the right angle. We're looking for this green one here. And so to find this green one, if we think about it, as I go around, this first part from here to here is 180, and then I had to go a little bit more. So the easiest way to find the green angle is to do 210 degrees minus 180 degrees. That's going to tell me how much more past 180 I had to go. So you can do 180 minus 210. You'll get a negative answer, and when you get that negative answer, then you want to remember you have to turn it positive. So it's a little easier to flip-flop the subtraction around at the beginning. So 210 minus 80 degrees actually gives us 30 degrees. Now, my original problem started in radians. So I have to now take that 30 degrees and multiply by pi over 180 degrees to get it back into radians. Yeah, if it was, well, so 270 is a little special. So any ones that end up on like one of the spikes, I call them, of the axes, they're a little bit special, and we have to take care of them a little bit differently. And we're actually going to do that next class. Okay, so here the 30 goes into, so 30 goes into 30 one time, 30 goes into the 6 times, and so we're left with pi over 6. Okay, so I have some people telling me they didn't understand this problem. So we started with 7 pi over 6. So the very first thing I did was I converted it to degrees, because it's a little easier to think about things in terms of degrees. So 7 pi over 6 turns out to be 210 degrees. So 210 degrees is this part here. And then I drew the angle. And then I drew the reference triangle. And all I'm trying to get now is this green part. And so you don't have to worry about the blue part was to kind of explain what some people were writing, but the blue part has nothing to do with the problem that was given at hand. So I want to find the green part. I know that from here to here is 210 degrees. And I know that from here to here is 180 degrees. So that's why I'm just going to do my whole entire angle, the 210, minus the 180 to get me the 30 degrees. And then because the problem started in radians, I have to give an answer in radians. So I have to go back to radians. Questions? No problem. Okay, so why are reference triangles helpful? They're helpful because now I could do a problem like this, which these will be more like the problems we're going to do next class, which is why we've kind of need reference triangles. But for example, so find the values of the 6 trig functions for the angle theta. And I need to think about this for a second because I'm making it up off the fly. Theta equal 240 degrees. Okay, so 240 degrees ends up down here in this quadrant someplace. So this whole entire part here is 240 degrees. And I'm going to end up making my reference triangle. Carrie, I don't remember what you said no to. Was it that I asked, does that make sense? So is there something you need me to explain more? It's so hard in the virtual world, right? Because it's like I'm trying to read the stuff you guys put in the chat and teach at the same time. So sometimes I miss the context clue as to what the chat is saying. So if you have a question, stick it in there. I'm happy to go back and explain anything. Okay, so I have this 240 degrees. I have to figure out the reference angle. So how am I going to find that reference angle? Okay, so so 240 minus 180, which ends up being 60 degrees. So this reference angle here is 60 degrees. So what we have is we have one of those special right triangles, 30, 60, 90, right? So I have the 90 degrees, the 60 degrees, that makes this 30 degrees. Because remember, all the angles in a right triangle have to add up to 180 degrees. Why is it? Okay, it's 180 because from here to here, so this pink part, that is a straight line, and a straight line is 180 degrees. So the pink part here is 180 degrees, and then I want to figure out what's the green part, right? The green part lines up to give me that whole angle. So the pink part and the green part together make the whole angle. So I'm taking the 240 and I'm taking away the pink part, and I'll just be left with the green part. Does that help? No problem. So most of the time, the things you're referencing are either 360. You're usually subtracting something from 360, or you're using 180 in some ways. You're either doing 180 minus something or something minus 180. Okay, so last class we talked about the special right triangles. I think it was last class. And how the sides in a 30, 60, 90 triangle have a certain relationship. So remember, the side across from the 30 we said was a 1. The side across from the 60 was a root 3, and the hypotenuse was a 2. So that's... Yeah, Morgan, so you can think of it that way. You're never going... A better way to think about it is to think you're never going to use something that's on this vertical axis, because the reference triangles don't have to do with this vertical axis. So you're either using 180 because you went this much, or you went all the way over here to 360. So sometimes you do use a number that's bigger than the angle. So I don't want you to think you can't ever use a number bigger than the angle, but we're always using the things that would be on the horizontal. Does that help? No problem. Okay, so that 1, square root of 3, and 2, I just got from last class, right? Last class we talked about in a special right triangle, right? There were 2 special right triangles. One was the 30, 60, 90, and one was the 45, 45, 90. And in the 30, 60, 90, it was 1, the hypotenuse was 2, and this was root 3. And in the 45, 45, 90, it was 1, 1, root 2. So those were the special right triangles, the dimensions on the special right triangle. So I just applied those values here. Now, one of the things to look out for is that here, the 1, if you think about it, if I move to the left here, did I move a positive 1 or did I move a negative 1? Negative. So we're really talking about negative 1. Same thing, when I moved this direction here, this square root of 3 down, did I move a positive in the positive direction or the negative direction? Yeah, so I moved the negative direction as well. So this is also a negative, right? So I have to think about where I am, whether they are positive or negative. And now that I have all those sides, I can figure out what the sine of theta is, the cosine of theta, the tangent of theta. Right? So the sine is going to be minus square root of 3 over 2. The cosine is the adjacent, so minus 1 over 2. And the tangent is the opposite, minus square root of 3 over the adjacent, minus 1, or just square root of 3. And then I'm going to flip them over. So the cosecant of theta is going to be minus 2 over square root of 3. The secant of theta is going to be minus 2 over 1, or negative 2. And the cotangent of theta is going to be 1 over the square root of 3. Questions? No. We're okay with this so far? All right, why don't I do one more like this? So, find the values of the 6 trig functions for theta equals 135 degrees. So 135 degrees is in the second quadrant here. So from here to here is 135 degrees. So again, my reference triangle, I'm going to draw it down to the x-axis. So my reference triangle, we have to figure out how many degrees that green part is. So how could I figure out what that is? Right, so 180 degrees minus 135 degrees gives me 45 degrees. So in here we have 45 degrees. Okay, and then that means I have a 45, 45, 90 triangle, which again is one of those special right triangles. So we have 1, 1, square root of 2. But now I have to check about the x and the y if any of them should be negative. So should the x that's horizontal, should this one here, should this be positive or should this be negative? Negative, right. And then this one here, should this be positive or should this be negative? Okay, so remember, this direction, when you go up here, right, these values here are all along the axis, they're all positive values. So when I go up from the x-axis, we're talking about positive. So yeah, so that's just going to stay a positive 1. And now, again, we can just find those 6 trig values. So the sine of theta, the cosine of theta, the tangent of theta, and then the cosecant of theta, the secant of theta, and the cotangent of theta. So what would the sine here be? So how do we find the sine? Yeah, 1 over the square root of 2, right. So the opposite side is 1, and the hypotenuse is square root of 2. What about the cosine? Yep, so the cosine is going to be negative 1 over the square root of 2. And then the tangent would be what? Yeah, so the tangent would be negative 1 because it's the opposite 1 divided by negative 1. And that just turns out to be negative 1. And then I'm just going to flip them over. So the cosecant would be square root of 2 over 1, which is just square root of 2. The secant would be negative square root of 2 over 1, which is just negative square root of 2. And the cotangent is just going to be, when you flip over a negative 1, it's still just negative 1. Questions? No? Okay. So, there's one more thing we're going to look at, and that is we're going to look at the signs of the trig functions. So, signs of trig functions. So whether the trig functions are positive or negative is basically what we're talking about. Okay, so I'm going to draw here a fairly decent sized XY plane so that we can kind of talk about some of this stuff. Now, a couple things for us to remember. So we're going to go back to, at the beginning of class, right? Remember I said that the sine of theta was y over r, the cosine of theta was x over r, and the tangent of theta was y over x. And that also, remember, the sine and the cosecant are related, so the cosecant of theta here would be r over y, the secant of theta would be r over x, And the cotangent of theta would be x over y. Okay, so we're going to come back to this definition here in a second. The first thing we're going to do is let's just talk about points and things in this general xy plane. So if you are in this xy plane, if I went out this way, right, the x values, as I move along this axis here, what are those x values? Are they positive numbers or are they negative numbers? Okay, they're positive. So in quadrant 1, right, so this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So in quadrant 1, the x's are positive. X's are positive. And also in quadrant 4, right, the x's are positive. And if I go out this way, what are the x's? Are they positive or negative if I'm going this direction? Yeah, in that direction, they're negative. So here, the x's are negative. And here, the x's are negative. Okay, so we're going to do a similar thing for the y's. So up here, so if I'm going up this way, right, are my y's positive or are my y's negative? Positive, yep. So y's are positive. Y's positive. And what happens down this way? Yeah, down that way they're negative. So the y's are negative. Y's negative. Okay, so that just tells us kind of about x and y in those quadrants, but we can now use that to tell us about the different functions. So in each of these quadrants, we're going to talk about the trig functions, the positive trig, positive trig, and then we'll also write down what the negative trig functions are. So we're going to do that in each of these quadrants. So the positive trig functions and the negative trig functions. Let me kind of move this guy down a little bit. Same thing here. Oops. So the positive trig functions and the negative trig. Same thing, positive trig and the negative trig. Okay, so we're going to go through in each quadrant, we're going to determine what is what. So, in the first quadrant, x's are positive, y's are positive. Remember, r's are always positive. So if everything over here is positive, x's are positive, y's are positive, r's are positive, all the trig functions are positive in this quadrant. And the negative trig functions, there aren't any. So none of them are negative. So in that first quadrant, because all my x's are positive, all my y's are positive, and r is always positive, everything just turns out to be positive. Okay. In the second quadrant, x's are negative, y's are positive. So if y is positive, that means the sine function is a positive trig one. So the sine of theta. Cosine has x over r, so x is negative, r is positive. So cosine of theta is going to go over here. Tangent has y over x. So x is negative, but y is positive. So I have one positive, one negative. So the tangent of theta is going to also be negative. And then if the sine is negative or the sine is positive, that also means the cosecant would be the same thing. So since the sine is positive, the cosecant of theta is also positive. Since the cosine is negative, the secant is going to be negative, and the cotangent is also going to be negative since the tangent is negative. Questions so far? No. Okay, we're going to do the same thing for down here. So here they're both negative. So since sine is y over r and y is negative and r is positive, the sine is going to go in this, is going to be negative. Cosine is x over r and x is negative, but r is positive. So cosine is going to go in this quadrant. Tangent is y over x, but if y is negative and x is negative, those two negatives would cancel each other out. So the tangent actually ends up being positive in this quadrant. And then again, if the tangent is positive, the cotangent is positive. If the sine is negative, the cosecant is negative. If the cosine is negative, the secant is negative. And then to do the same thing here for the last quadrant. So in this quadrant, x's are positive, but y's are negative. So since y is negative, the sine would end up being negative. Since x is positive, the cosine ends up being positive. Since tangent is y over x, one is positive, one is negative, the tangent ends up being negative. And then again, if the cosine's positive, the secant is positive. If the sine is negative, the cosecant is negative. If the tangent is negative, the cotangent is negative. So that's where all these positive and negatives come from. However, there actually is a little mnemonic to help you remember it, so you don't have to go through everything we just went through. So I went through all of that to show you where it comes from. But the mnemonic to remember is you have to start in quadrant 1 and you have to move all around the quadrants in the correct order. So you have to go quadrant 1, quadrant 2, quadrant 3, quadrant 4. But if you remember, all students take calculus, right? All students take calculus helps you remember what is positive. So all the trig functions are positive here. S goes with sine. Sine is the trig function that's positive, and if sine is positive, then cosecant is positive. Take goes with tangent, t. So the tangent is positive, and the tangent is positive, then cotangent is positive. And calculus, C, the C stands for the cosine. So if the cosine is if the cosine is positive, then the secant is positive. So the little mnemonic, all students take calculus, helps you to remember which quadrants things are positive and negative in. Questions so far? Yeah, it's a cute little thing to remind you, right? You don't have to remember all that other stuff I did. So now I can ask questions like this. In what quadrant is A, cosine of theta bigger than 0 and sine theta less than 0? Okay, so cosine of theta being when we put greater than 0, that's really just our fancy math way of saying positive or negative. So if I'm bigger than 0, if I'm greater than 0, am I positive or negative? Yeah, I'm positive. So this is saying I need the cosine to be positive. And what about the sine? Are we looking for the sine to be positive or negative? So cosine of theta needs to be positive. Sine of theta needs to be negative. Okay. So now we got to look. Which one of our 4 quadrants has the cosine being positive but the sine being negative? Yeah, the 4th one. So this answer here is quadrant 4. So we'll do one more here. What about the sine of theta being greater than 0 and the secant of theta being less than 0? So we're saying the sine is positive and the secant is negative. So which quadrant has the sine positive and the secant negative? Yeah, 2. Quadrant 2. Questions? No. Okay, so I have one more example then that deals kind of with this and ties into what we were doing before. So let theta be an angle such that the secant of theta is equal to negative 13 over 5, and the cotangent of theta is greater than 0. Find the tangent of theta and the cosecant of theta. Okay, so the first order of business is we have to figure out what quadrant our angle is sitting in. Okay, so they didn't tell us. They didn't say, hey, I have an angle and that angle is in quadrant 2, or I have an angle and that angle is in quadrant 3. They gave us information. They said, okay, the secant is negative, but the cotangent is positive. So if you look back at your notes, we're looking for a quadrant where the secant is negative. So remember, the secant deals with the cosine. Secant and cosine are tied together. So we're looking for where the cosine is negative, or the secant is negative. And the secant is negative in quadrants 2 and quadrants 4. So quadrants 2 and quadrants 4 have the secant being negative. And then we want to look at, well, where is the cotangent positive? So the cotangent is positive in quadrants 1, because all the trig functions are positive in quadrant 1, and also quadrant 3. So I'm looking for both of these conditions to happen. So both of these conditions are happening here in quadrant 3, which means my angle has to be someplace here in quadrant 3. So that's where my angle theta has to be. And I'm just going to draw that reference triangle. And then secant, what do we remember about secant? So you could either say it in terms of x's and y's and r's, or you could say it in terms of like opposite or adjacent hypotenuse. What are the dimensions on secant? It's what over what? Okay, so secant is r over x. So here, right, we were given that the secant of theta is negative 13 over 5, and we need to remember that that's r over x. So what that's telling us is our r, we have 13, and our x is 5. Now, I have to figure out where the negative goes, because remember in math, we can put the negative anywhere we want. So we wrote it as negative 13 over 5, but the negative may not go with the 13. So what do you think the negative goes with? Should it go with on the 13 or on the 5? Yeah, it's going to go on the 5 because the 5 is on that negative part there. So this is negative 5. And then we have to use Pythagorean Theorem to find that missing side. So Pythagorean theorem is going to say a squared plus b squared equals c squared. So we're going to have negative 5 squared plus b squared equals 13 squared. So 25 plus b squared equals 169. If I subtract, r is always positive. R is always going to be positive. You can't put the negative with the r. If I subtract 25 from both sides, b squared is going to be equal to 144. So b is going to be equal to plus or minus the square root of 144, which is plus or minus 12. Okay, so we're going to determine if it should be a positive 12 or a negative 12 by looking at where this is. So we're going down here. So should it be a positive 12 or a negative 12? Yeah, negative. So this side here is negative 12. So now I have all my sides, right? I have negative 5, negative 12. I have the 13. So all I have to do now is figure out the problems they were looking for. So remember, we were looking for the tangent of theta, which we said you can either think of it as opposite over adjacent or y over x. So it's going to be negative 12 over negative 5 or 12 over 5. And we were looking for the cotangent of, not the cotangent. We were looking for the cosecant of theta. And so remember, cosecant of theta is hypotenuse over the opposite, or hypotenuse, or r over y. So this is going to be the r, which is 13, over the y, which is negative 12. And you could leave it that way with the negative in the bottom. You could put the negative in the top. You could put the negative out in front. You could put it wherever you want. Questions? It is cosine instead of cosecant. No, it is cosecant. So remember, cosecant is different than cosine. Are you saying like here? Are you asking if that's the cosine instead of the cosecant? I think I'm not exactly sure what your question is, Liana. Are you sure? Okay. Other questions? No. Okay. So then that's the end of section 4.4. And the homework that's due this Friday only covers what we learned last Wednesday, which was 4.3, and what we learned today, which is 4.4. So you right now have all the knowledge you need to do the homework that's due on Friday. I don't remember how many questions there are. I don't know off. Wait a minute. I can look. Hold on one second. It is, let me see, 5. It's probably 5, 8, 7. So it's 12. There should be 12 topics, but remember, like, everybody might not have 12 to do, right? Because depending what you got from that initial knowledge check, you might have gotten some of the questions or some of the topics for that set to begin with, like already. But it would be, technically there's 12 different topics in this homework. Other questions? Well, if you have any questions, you want to hang around and ask, feel free. Otherwise, I will see you guys on Wednesday. No problem. Have a good one.